sometimes you will have radicals inside an equation in which you have to solve for a variable. Sometimes there'll be inequalities. And the goal is, yes, you're trying to solve for the variable, but the goal is to get rid of those radical signs as quickly as possible, because then it's going to be turned into a regular algebra problem, which is your goal. For instance, if I were to have the square root of x minus 8 equals 0. So in this case, my variable is attached to the radical. And since I have that additional 8 on that side, I'm going to have to move it. So your first goal here is to get the radical by itself on one side. So in this case, I'm going to add the 8. And now I have a situation where I've got the radical alone on one side. So I'm going to go ahead and square both sides in order to get rid of that radical. So x equals 64. One of the bad things about this, there isn't really like a steps, because each situation is different. But that's something we're going to have to work through. Also, double check to make sure solution is possible. Actually, determine if it's real, not necessarily possible. Because remember, technically you can't have a negative square root. So if this happened to be x equals negative 64, we would say that was a no solution, because you can't have the square root of 64, negative 64, unless you're dealing with imaginary numbers. But in this case, we aren't. All right, so let's work on a different situation here, where we've got some other things that are attached. Let's say that I've got x minus 4 equals x square root 3. All right, so looking at this, I can see here that I've got x's on two different sides. That's a problem. So yes, I have a radical that's attached with the x and I could divide by x, but that x actually goes into everything. So we want the x's on the same side. This is where I'm saying you don't always have a situation where it's the same each time. So we're going to have negative 4 equals x square root 3 minus x. Now, this is a situation where the x's on the right-hand side are in both terms. I can factor that out. X is my GCF. So if I factor that x out, I've got the x now alone in terms of that it's being multiplied by that square root 3 minus 1. And I know here that the x's, I've got a single x where I started with two x's. I'm going to go ahead and divide then by that square root 3 minus 1. So now we've got negative 4 divided by the square root 3 minus 1 equals x. Remember how we couldn't have complex numbers, aka imaginary numbers, in our denominator? Same thing applies with the radical sign. You can't have that radical sign in the denominator. You multiply the top and the bottom by the conjugate. So not the complex conjugate. A complex conjugate is with imaginary numbers. Notice, what got changed was the square root sign. It was not the sign that you see there. It was in front of the square root. So just make sure you remember that. It's in front of the square root or in front of the imaginary number. So I'm going to do some multiplication there with my conjugate. And I've got 4 square root 3 plus 4 over negative 3. And then we've got a plus square root 3 minus square root 3 plus 1 equals x. I'm going to simplify some stuff here. Notice I've got a -2, a 4, and a 4. I can reduce all of this. So it's -2 plus or minus, not plus or minus, sorry, minus 2 square root 3 equals x. All right, let's go with an inequality this time. Yes, this is an inequality, but it doesn't really change a whole lot in terms of what we are trying to do. And that's a good thing, realistically. Right now, we've got two different radical signs, which could create a problem, but it won't be that big of a deal. Since we have two separate radicals, when we square it, it's going to be a nightmare if we use it on both sides, or on just one side. So we're going to move one of the square roots to the other side. So I've got the square root of x minus 5 is less than or equal to 4 plus the square root of x plus 7. Okay, I know it looks kind of crazy, but we have to get rid of that radical sign. We're going to get rid of that radical sign by squaring both sides. When we do this, on the left-hand side, the square of a square root just leaves it as underneath. On the other side, I'm going to rewrite this because a lot of people forget that this is listed twice and they forget the middle term when they do this. So I'm going to have to do some distribution on the right-hand side. So I've got 16 plus 4 square root x plus 7 plus 4 square root x plus 7 plus x plus 7. Now, I didn't actually get rid of the square root on that right-hand side, but it's okay because I got rid of one of the square roots out of the two. We're just going to combine some like terms here. Okay, so those first two numbers do not have any square roots, any radical signs whatsoever. So I'm going to move those over to the left. I'm going to subtract the x, and I'm going to subtract the 23. Well, when I do that, that actually cancels out the x on the left-hand side, which is okay. All right, so there's a number attached with that x plus 7. So I'm going to get rid of that 8 by division. This is going to give me a decimal, and that's okay. I'm now down to a single square root, so I'm going to go ahead and square both sides. This is a positive 12.25, and this gives me an x plus 7. I can now subtract the 7, and I'm done. Like I said, there is not a set process on how to do this. This is just something, the more you practice it, the more you are likely to see how things work and how you can connect them to get it down to a single variable. My biggest trick is to get, if you have two, get one on one side and one radical on the other side, then work it out. You might have to do some squaring twice to both sides, and that's okay. But at least when you square once, you'll get rid of one side.